So in this problem, we're asked to determine what is the moment of inertia for the area that is below uh, the x-axis, or about the shaded area below about the x-axis. So what we're looking for is we're looking for I of x. Okay, so we can do this using two formulas. All right, so the first case, case one, what we're going to do is we're going to show you how to do this problem when you have the element or differential element is parallel with the x-axis. Okay. So that's what we have drawn here. All right, so for that equation, we know that I of x would be equal to the integral of y squared dA. Right? So we need to first define what our dA is equal to. So for our horizontal element, we know that dA would be equal to the width, which is going to be equal to 100 millimeters minus x times the height, which is equal to dy. Right? So we know that y squared is equal to 400x. So we can relate x would be equal to y squared over 400. Right? So if we plug all this in, what we end up getting is we get the integral, so you go to y squared times dA, which is going to be equal to 100 millimeters minus x, but we're going to plug in for x, we're going to plug in y squared over 400. All right, and then we're going to, and then the last thing we'll have is that we'll get multiplied by dy. Right, and then y goes from 0 millimeters in this case to 200 millimeters. Right. So if we do this, if we distribute this all out, what we end up getting is we get 100 millimeters times y squared minus y to the fourth over 400 d of y. If we integrate that again, what we'll end up getting is we get 100 millimeters y cubed over 3 minus y to the fifth over 2000. And we have to evaluate that from 200 millimeters to 0 millimeters. All right, if we plug those in, what we'll end up getting is we'll get 100 over 3 times 200 squared, or 200 cubed, minus 200, 200 to the fifth over 2000. All right, and then for the second, from when we plug in y is equal to 0, we get 0 minus 0. So if you evaluate all of that, we end up getting 106 point, we get, we did this integral, we end up getting 800 over 3 times 10 to the 6th millimeters to the fourth minus 160 times 10 to the 6th millimeters to the fourth, which ends up being 106.7 millimeters to the 4 times 10 to the 6th millimeters to the fourth, which is approximately equal to 107 times 10 to the 6th millimeters to the 4th. Right. Right. So, so that's for the first case. So for the in-class assignment, I'd like you to try the second case, which is when you have you want you to use the parallel axis theorem. All right, and I want you to try to solve dix. I want you to solve for solve for ix again, but in the case of the case 2, our element is perpendicular with our axis. All right. All right. So we know. All right. So I'd like you, if you're in the class, to stop here and try to solve this on your own. So go back in the packet a couple pages so you can look at the equation that you would need to solve in order to determine the moment of inertia. Right? So, okay, so in here, I'm going to solve for I of x. So what we're going to use is we're going to use the parallel axis theorem. So we're going to say that di of x is going to be equal to d I x prime, so it's the moment of inertia by the centroid, plus the differential area times the distance to the centroid from the x-axis squared. Right, so we need to define each of these terms. All right, so we'll do di of x first. So we know that for this element here, the last example, we know for a rectangular element that the moment of inertia is equal to 1/12 times the base, which in this case is dx, times the height, which in this case is y, right? Cubed, right? So since everything is in terms of dx, you want to put y in terms of x, so we know that y would be equal to square root of 400x, right? So if we plug that in, we would get 1/12 dx times square 400x to the 3 halves. Okay, so now we have I of x defined, and we need to define what is dA and dA dy. Um, so if we define dA, dA is equal to y dx. All right, so we can plug in y is going to be equal to square root of 400x dx, right? And then for dy prime, you know that's going to be equal to, that's the distance from the x-axis to the centroid, so that's going to be equal to y over 2. So we know that y is equal to square root of 400x divided by 2. So if we bring the 2 into the square root, we end up getting just the square root of 100x, and then dy prime squared would be equal to 100x. So if we bring this all together, we can integrate both sides of the start equation here, and we can solve for I of x. So we're going to break this into two integrals. So we'll solve for I of x prime first. So that would be equal to the so if you so that would be equal to the integral from 0 to 100 millimeters of 1/12 times 400 x to the 3/2 dx, which is equal to 2000 over 3 times the integral from 0 to 100 millimeters times x to the 3/2, which would be equal to so it's equal to 2000 times 2/5 times x to the 5/2 from 0 millimeters to 100 millimeters. So if we put in 100 into our square root term, what we end up getting here is we get 8 you get 80 80 divided by 3 times 10 to the 6th millimeters to the 4th, right? All right, so then we can also solve for the integral of, we can solve for a dy squared, which is just the integral of dA dy prime squared, which would be equal to integral from 0 to 100 millimeters which is going to be equal to the square root of 400 x dx times 100x. So the square root of 400 is just 20, so that you can take out 2000 from this integral, and then we're going to get x to the 3/2 dx. So we're going to end up with 2000 times 2/5 times x to the 5/2 from 100 millimeters, 0 millimeters, and then we're going to get, if we plug in those, we'll end up getting if we plug all that in, we'll get 80 times 10 to the 6th millimeters to the 4th. If we add all those together, we'll end up getting I of x is going to be equal to 106.7 times 10 to the 4th, 10 to the 6th millimeters to the 4th, which is again approximately equal to 107 times 10 to the 6th millimeters. So that concludes this example problem on how to solve for the moment of inertia using an element that's parallel with the axis and an element that is perpendicular